Hey everyone, welcome to All About Python. In this three-part course, you shall learn about basic Python syntax, Python data structure, NumPy, and pandas. All you need to know before learning machine learning and Python TensorFlow. In the previous video, we had covered the basics of Python programming language, which entails variables, operators, basic data types, conditional statements, and loops. In the second part, we'll delve into the fascinating world of Python data structures and functions. We'll explore the concept of lists, tuples, dictionaries, and functions, which are crucial for building powerful and efficient Python programs. So, let's get started. Before we jump into learning about the various data structures, let's talk about what data structures really are. Data structures are a fundamental concept in programming that allows us to organize, store, and manipulate data efficiently. In Python, data structures are classified into two main categories: mutable and immutable. Mutable data structures are those that can be modified or changed after they are created. On the other hand, immutable data structures are fixed and cannot be altered once they have been created. Mutable data structures are highly flexible and allow us to modify, add, or remove elements as needed. Example of mutable data structures would be Python and dictionaries, whereas immutable data structures cannot be changed once created. They offer data integrity and ensure that the values remain constant throughout the programs. Example of an immutable data structure would be tuples. Now that we have covered the distinction between mutable and immutable data structures, let's delve into the types of data structures. We'll start with lists, which are a fundamental and versatile mutable data structure in Python. Lists allows us to store and manipulate collection of elements. They are ordered, meaning the elements are positioned in a specific sequence. You can create lists in Python using the square brackets or the list function. To start understanding the concept of lists in details, let's look at the different ways we can create a list. In this example, we have multiple lists: list 1, list 2, list 3, and list 4. Each list contains elements of various types such as integers, boolean, strings, and even another list. We can create lists using the square bracket or the list function. As we can see in this example, lists can store different types of data, making them highly flexible for various programming tasks. Okay. Now consider a scenario where we have a list with duplicate items. In this following example, we have list 5, which contains repeated elements. And duplicate items can be useful in some cases. So Python allows us to include them in a list. We also can see in list 6 we have our list containing data types or containing items of various data types. Now let's look at how we can access various items in a list. Accessing individual elements in a list is straightforward. In this code snippet, we can demonstrate how to access list by the indices. We use list 1 as an example and show how to access the first element, that is the index 0, and the last element using negative indexing. If we print these, we can get the output as 1 and 5, since the first and the last element of list 1 are 1 and 5. Determining the size of a list is useful in various situations. There are a couple of ways of achieving it. Python has a built-in function called the len function, which directly returns the length of a list. There is also a second method in which we can manually count the number of elements in a list using a for loop, which we had discussed in the previous video. Both approaches provide us the same result and give us the number of elements in the list to be as 5. Sometimes we may need to insert elements at a specific position in a list. Python provides us with various ways to accomplish this task. In this following code snippet, we have demonstrated two methods of inserting elements into list 1. Number 1 is using the insert method, and then we have used the slice assignment. In the first method, we use the insert method,
to add the element 0 at the beginning of the list, shifting all of the elements to the right. In the second method, we perform the slice assignment to insert in 1.5 and index 1, effectively expanding the list and accommodating the new element. As you can see from the output over here, when we insert, the final list is 0, 1.5, 1, 2, 3, 4, and 5. Python allows us to concatenate lists, which means combining multiple lists into a single list. In the following code snippet, we demonstrate how to concatenate list 1 and list 2. By using the plus operator, we can merge in the elements of both lists and create a new list that contains all the elements of the desired order. As you can see that when we concatenate list 1 and list 2, we get the output as 0, 1.5, 1, 2, 3, 4, 5, and then we get the elements of list 2 over here. Let's now explore adding elements to a list in Python. Python provides different methods for appending elements at the end of a list or extending a list with multiple elements. In the next code snippet, we demonstrate both approaches using list 1. In the first method, we use the append function and add element 6 at the end of the list. In the second one, we concatenate to append element 7 to the existing list. When we print list 1, we can see the output to be 0, 1.5, 1, 2, 3, 4, 5, 6, and 7. List slicing allows us to extract specific subsets of a list by specifying the start and end indices. In the next code snippet, we can demonstrate how different list slices of list 1, as slice 1, slice 2, and slice 3. In the first slice, we extract elements from index 2 to 4 and get the output as 4, 3, 2. In the next one, we can see we have asked to retrieve elements from the start to index 2, which gives us the output as 6, 5, 4. And in the third one, we have asked to extract elements from index 4 to the end of the list, which gives us the output as 2, 1, and 0. Reversing the order of elements in a list is a common operation in Python. There are multiple ways to achieve this. In the next code snippet, we demonstrate two methods, the reverse function and using slicing. In the first method, we use the built-in reverse function to reverse the order of the elements given in list 1. In the second method, we utilize the step counter which we had discussed in the first video. Here you can see that we are slicing the list with a step counter of -1 to achieve the same result, creating a new list called the reversed list. As you can see that when we print both the lists, we can get the following output as 7, 6, 5, 4, 3, 2, 1, 1.5 and 0, and when we are printing the reverse list, we are getting the list 1 as we had given it originally over here. Removing elements of a list can be done using different methods. In the next code snippet, we demonstrate the two approaches, using the built-in remove function and using the del statement. In the first method, we use the remove function to remove the element 1.5, and in the next method, we use the del statement followed by the index number that we want to delete. So as you can see, when we print the list, we get an output something like this over here.
Now let's look at tuples. Tuples are immutable, ordered collection of elements. They offer data integrity and ensure that the values remain constant throughout the program. Let's delve into tuples and understand them through some examples.
To start, let's look at how to create a tuple. In this example, we have multiple tuples, tuple 1, tuple 2, tuple 3, and tuple 4. Each tuple contains elements of different types such as integer, boolean, and strings. We can create tuple using the parentheses or the tuple function as we have done over here. Just like in case of list, we can also have tuples with values of varying data types. We can also have tuples with duplicate items, and we can also access elements of a particular tuple using square brackets and mentioning the index number of the tuple we want to access. Just like in lists, we can also concatenate two tuples and create a third tuple to store the value of both the tuples in one single tuple. Now let's look at how we can concatenate a list with a tuple. Lists and tuples can be combined by converting one of them to the other type. In this following snippet, we have demonstrated how we have concatenated tuple 1 with a list called list1. As you can see over here, we have converted tuple 1 into a list and then printed the concatenated list as 0, 1, 2, 3, 4, 5, 6, 7, 8. Tuple slicing allows us to extract specific subsets of a tuple by specifying the start and the end indices. In the next code snippet, we can demonstrate the different slices of tuple 7 as slice 1, slice 2, and slice 3. By specifying the start and the end indices within square brackets, we extract specific portions of the tuple. These slices create new tuples containing the selected elements. Since tuples are immutable, we cannot directly insert elements into an existing tuple. However, we can create a new tuple by combining portions of the original tuple and the desired element. In the following code snippet, we demonstrate how we can insert element 99 into the third position of the tuple 1. As you can see, we have taken a tuple int and then we have distributed the original tuple 1 as tuple 1 and then we have sliced it in the first half from the till index 2. Then we have added the element 99 and then we have considered the tuple from 1 from index 2 till the very end. Now, if we can check tuple 8, we can see the output to be 1, 2, 99, 3, 4, and 5. As you can see, we have inserted element number 99 in the third position of the 8th tuple. Just like in lists, we can reverse the tuple. We can reverse a particular tuple using the step counter, as we have done over here. In tuple, removing elements is not possible since tuples are immutable. Once a tuple is created, its elements cannot be modified. However, you can create a new tuple without the unwanted elements. If you need to completely remove a tuple from the memory, you can use the del statement. In the following code snippet, we have demonstrated how to delete a particular tuple. After deleting the tuple, any attempt to access it will result in a name error, as we have shown over here. Tuples can also be stored into a list, and conversely, a list can be stored as a tuple. As you can see in this first example, we have a list called list of tuples, and that contains tuples as its element. In the second example, we have converted the list 1 into a tuple using the tuple function and storing it in the tuple of list. When we print them, we get the following output as we can see over here.
Moving on to dictionaries, which falls under the mutable category. Dictionaries are a highly efficient and versatile data structure for storing key value pairs. Dictionaries are unordered that allows us to retrieve values based on its unique keys. They are created using the curly braces or the dict function. Let's delve into dictionaries using some code snippets and understand the concept through some examples.
To begin, let's look at the different ways we can create a dictionary. In Python, we can create a dictionary using the curly braces, the dict constructor, or a list of tuples. In the first example, we create a dictionary called myDict using the curly braces, specifying the key value pairs. In the second example, we use the dict constructor with named arguments. Finally, in the third, we create a dictionary by passing a list of tuples where each tuple represents a key value pair. Unlike in lists and tuples, dictionaries cannot have duplicate keys. If a key is repeated, the last value assigned to it is the one that is stored. Dictionaries can also be nested. meaning that the values in a dictionary themselves can be dictionaries. Let's look at this example. Here we have taken mydict5 that contains two keys, fruits and vegetables. The value assigned with the keys themselves here are dictionaries. Dictionaries can store various data types such as strings, numbers, booleans, or even lists. In this case, we have taken mydict6 that stores information about a certain person. The values can be of different data types, making dictionaries flexible in handling diverse data. Adding elements to a dictionary and accessing them is pretty straightforward. Let's look at these examples. Over here, we have taken the key orange with the associated value 4 to mydict. In the second example, we add the key orange with the associated value 4 to the next dictionary, mydict5, fruit. And when we print them using the corresponding keys, we get the outputs as 1 and 2. In Python, negative indexing is not possible. We can remove elements from a dictionary using the del keyword. Let's look at this example over here. In this case, we want to delete the key cherry and its associated value from a particular dictionary. So we have used del, then the name of the dictionary mydict, and then the key cherry. And when we print this, you can see that the cherry keyword has been removed. To determine the number of key value pairs in a dictionary, we can use the built-in len function of Python, like we have done over here in this case. When we print the dictionary, the len of the dictionary, this dictionary mydict, you can see that the output shown over here will be 3. Concatenating dictionaries allows us to merge two dictionaries into one. Let's explore using the following example over here. In this case, we have used the update function to merge the dictionaries mydict and mydict2, updating the former with the key value pairs from the latter. When we print the dictionary mydict, you can see that the output will be a summation of both the dictionaries. Unlike lists, dictionaries don't have an append operation. Instead, we add new key value pairs directly by assigning a value to the new key. Let's look at this example over here. Here we have taken the key gray with the associated value 5 and added it to the dictionary mydict. When we print it, we can see that the value key has been the value gray has been added over here with the value 5. Reversing or swapping the key value pairs in a dictionary can be achieved by using a dictionary comprehension. Let's look at this example over here. In this case, we use the dictionary comprehension to create a new dictionary, reverse dicts, to where the key and the values are reversed from the original my dictionary. And when we print it, we can see that we have the reversed values over here. Slicing a dictionary doesn't have a direct equivalent operation like that of in lists or tuples. However, we can achieve similar result using dictionary comprehension. If you look at this example over here, we have taken a new dictionary, sliced dict, and by extracting the specific key value pairs from my dictionary using dictionary comprehension like we have done over here. Dictionaries can store list and tuples as its values. Let's say at this example over here. In this example, we have a dictionary called mydict7 that contains key values, fruits and numbers with the corresponding lists and tuples as its values. It is also possible to convert a string into a dictionary. Over here, if you see, we have taken a my string as apple1, apple equals to 1, banana equals to 2, cherry equals to 3. And we have created a dictionary, mydict8, where we have stored the values of my string using the dictor function over here. As we can see, when we print the mydict8, we get the following output.
Now that we have covered the data structures, let's explore functions, which is a fundamental concept in programming. Functions allow us to organize our code into reusable blocks, enhancing the code modularity and readability. Let's dive into function and understand it through some examples.
To begin, let's look at how to create a function in Python. In Python, we define a function by using the def keyword, followed by the function name and then parentheses. We also specify parameters within the parentheses which represent inputs for a function. In this example, we define the function greet, but then take a parameter name to print a personalized greeting. Once we have defined a function, we can call it to execute its code and perform the desired action. In this case, we call the greet function to pass the argument Arunama, resulting in the function printing the output hello Arunama. Function can take multiple arguments, allowing us to pass values for specific parameters and perform computations or operations based on these outputs. Let's explore this concept using an example. Over here, we have defined a function called add numbers and take arguments a and b and return their sum. We then call the function with the values 3 and 5 and store its result in the variable result, which we then print. Once we run it, we can see that the output returned to us is 8.
Python allows us to define functions that can accept a variable number of arguments. These arguments are often referred to as arbitrary or variable length arguments. Let's explore this concept using an example. Over here, we have a function called print_args that uses the pointer args syntax to accept an arbitrary number of arguments. We then split the user input into a list of values, and using the pointer operator, we pass these values as arguments to the print_args function. Let's say we have over here, we've been asked here to enter some values separated by spaces. So we give 6, hello world, and then as you can see over here, we have been returned the output hello world in 2 different lines.
Recursion is a powerful technique where a function calls itself during its execution. It allows for solving complex problems by breaking them into smaller, more manageable subproblems.
In the previous video, we had mentioned about how you can practice questions on Python basics and strengthen your skills at hackerrank.com. Did you know that HackerRank also provides a Python basic certification course? In 1.5 hours, you'll have to answer 2 coding questions. If you're able to solve the given questions, you'll be awarded a certificate, which you can also showcase in your CV. In conclusion, we explored the concepts of the various data structures that are used in Python, like lists, tuples, and dictionaries. And so, we looked at how functions work in Python. Understanding these fundamental concepts will give you a strong foundation for learning about machine learning and TensorFlow, which will be required in our upcoming bootcamp, which is being organized by Skepsis and GDSC SNU. Register now if you haven't yet already. The link is in the description. Thank you for joining us on this journey through Python data structures. We hope that you found this course informative and engaging. Remember to practice on HackerRank. Don't forget to check out the Python Basic Certification test, and we'll see you in the next one.